Hello students, welcome on to the next topic on the optimization techniques. In this lecture, we will study about the optimality conditions of the transportation problem, that is by using the Modi method, study some degenerate solutions and some special type of the optimization problems. Myself, Harish Garg. So in this here, we will quickly overview the transportation problem. Basically in this task, I just consider a single problem, okay, and then try to solve this single problem with the help of northwest, least cost and the WAM methods. And by using the Modi method, we calculate the optimal solutions and check how many steps are needed in each of the cases. Apart from it, some special types, some degenerate solutions are discussed in it, and the way of finding the optimal solutions are also be discussed in this presentation. So to address this, I just consider this transportation problem, and these are the warehouses are there and factories. I look at that this is clearly a balanced transportation problem, and whose uh, source and the supply is there 34. And I just solve this problem with the help of the northwest, least coast and the WAM methods and check their optimality conditions by using the Modi methods. So quickly solve this problem with the help of the firstly the northwest corner method. When you try to solve this northwest corner method, you will get these initial basic solutions. How do you get that? Look at that. The first northwest column is this, and what is the value of this? This is the maximum of 5 and the 7. So it will 5 and so on. Okay. So how many cells are there? There is 1, 2, 3, 4. It's a 4 cross 3. So you need a 4 plus 3 minus 1. That is m plus n minus 1. Okay. So it means 4 plus 3 minus 1. That is the 6 allocations are there and it occurs that. Now if you calculate the cost of them, that is 5 multiplied 2 plus 2 multiplied 3 plus 6 multiplied 3, you will get 102. So this is the initial cost. Now you will check that whether this cost is the optimal one or whether these allocations are the optimal or not, and this cost is optimal or not. So we apply the Modi method. So what is that? You need to find the allocations, that is the dual variables. So u1, u2, u3, u4, v1, v2 and v3. Okay, so how you find that? You can add one dummy values to any one of ui's or vj. So I can assign, say for example, here there are number of allocation, 2 are maximum, and here there also, so I assign here. Okay, so what is the value of this? So this plus this must be the cost value, so it will be the 3. This plus this must be the cost value, so it again 3. Now based on this you can find the value of this. This plus this must be equal to 2, so it will be minus 1. Now other value is this. For this you need u4 as well as a v3, but it is not possible. So based on these 3 you can calculate the value of this, so it will be plus 1. Okay, now with the help of plus 1 you can calculate this value. It will be by 6, and similarly now based on 6 and 2 you will calculate this one is 4. Okay, now you will calculate this dij, that is zj minus ej, for all those unoccupied cells. Okay, so these are my unoccupied cells are there. It means these are my non-basic variables, and check whether there is any entering variable or there is any leaving variable present or not. So what is those? So how to calculate ui plus vj minus cij? So 3 plus of minus 1 and minus of 7. So this is 2 and it comes to be minus 5. Similarly here is 5. 5 minus 4 is plus 1. Okay, this value is 6 minus 1 is plus 5. This is 3 plus 1 minus 5. This is minus 1. This is minus of 2. This is minus of 7. So check whether all dij are negative. No, these two values are positive. Okay, so you start with the most positive value. So this, assign epsilon value here, and you can move on these basic cells in such a way that you start from here and return at here. Okay, so I can go to this direction firstly, then this direction, and this is there. Okay, so this is my plus epsilon, this is minus epsilon, this is plus epsilon, this is minus epsilon. So what is the value of the epsilon is? I can get simply minimum of all those values which have a negative of epsilon. That is 4, negative epsilon is 6. Remember, this is always the allocations. So the value is my 4. So I can construct the second table. Here is 4. So I can construct here this epsilon is my 4. 4 minus 1, 4 minus 4, 0. So leave it. 3 plus 4. This is my 7. 6 minus 4, that is my 2. Okay, and we need a 6 allocations, and the remaining one is that is 5. So it is remains same. 2 3 is remains same. Okay, so one more is there, that is here 14. Okay, so if you calculate the cost, so what will be that? So either you can multiply 5 into 2, this into this, or so on, or otherwise you can use the previous value, that is 102 minus what's the value of the epsilon is 4, multiply with what is the entering variable. Entering variable is by this, that is epsilon is here, so that is 5. So that is if you solve them, what is the value of it? That is 5 or 20, 82. Okay, so either you can solve this 5 into 2, this and so on. So again, this is another way to check whether your answers are true or not. Now it means this is not an optimal one. So now check whether this is the optimal one. Now this is updated BFA 6 values. Okay, again you can check that here is a 5, so here's a 5, 8, 2 plus 2 plus 4, 8, 7, 14, and similarly for the column wise. At each step you can check your answers. Now again move on this one. You can assign the arbitrary values to firstly. So I can assign here because this is the maximum values. So this plus this is the Cij, that is a 3. This is again 3. This is 1. Based on these 3, I can calculate this one, that is -1. Based on this 3, I can calculate this value, that is 1. Or based on this 1, I can calculate this. Okay, so now I can calculate the unoccupied values are there. So this is 3 minus 1, that is 2, it is -5. Okay, this is my -4, this is there, this is my minus of 2, this is my 2, and this is my -5. Okay, this is my 4 minus 1, that is 3, and here is my 3 plus 1 4 minus 2, that is 3 plus 1 minus 4 is. So again all are non-negative, so it means it is not an optimal one. So if it is not optimal one, then you have to what is the entering variable, look at the most positive value here. So you can assign the value here epsilon. You start from here and ending at here. So you can go in this way or in this way, in such a way you can turn only through these basic cells. So if I go in that direction firstly, okay, if I go more then I can turn here, but there is no other way. So second is I can go in this way, then through this cell. Okay, but here there is no possible way are there, so it means this is not possible way. So I can go in that direction, so it means I can firstly remove this side, this is not be possible. Okay, so what is that? Now along this side, then on this, and then finally return back. So this is my plus epsilon, this is my minus epsilon, this is my plus, because here there is no epsilon because there is no turning point is there, and here is the minus epsilon. Okay, and here is plus. So what is the value of the epsilon is? This is minus, minimum of negative value is my 2. Okay, here negative value is my 14b. Okay, so there is my 2. So I just update these values. So I just use here, so I can rub these values and calculate the again values are there. Okay, so what are those? So here epsilon is my 2, so this value is my 2. Okay, so 2 minus 2 0, leave that. 4 plus 2, that is 6 here. 14 minus 2, that is 12. Okay, and the remaining values are same, the basic cells are this my 4, this is my 2. Okay, and this is my 7. Again you can check that whether your answer is 2 or not. This is 5, this is 8, this is 7, 7, and then so on. Now calculate the value of the u1 and u2, and what is the cost of it is. Now in this case, what is the cost is? Previous cost is my 82. If you multiply them 10, 6, 28, and so on, or other ways, you can say find 82 minus what's the epsilon of here in this case is 2, and what is the entering variable is? Entering is this one, that is a 3. So that is a 6. Okay, so that is a 76 is there, or otherwise you can multiply this and then so on. So again you will get the 76. So you will calculate the values of these u1, u2, u3, u4, and vi's are there. So again look at that. You can assign any values to be a 0. Okay, so I can say start with here. So this is my 3, this is now my 1. With the help of this one, I can calculate the value of u4. It is my 1. With the help of 3 I can calculate the value of this. This is 1. Now I can need one more value. So how can I calculate this value? So based on this value, that is 1 and this value is my 0. Okay, this plus this is come to be 1, and now this help of this is here. Okay, now quickly calculate the values of this, check whether these new solutions are optimal or not. So 3 plus 2 5, 5 minus 7 is my minus of 2, 2 plus 1 3 minus 1, 0 minus 3, this is basic, this is now non-basic, this is 0 plus 1 minus 5, okay, minus 4, this is my 1 plus 1 minus 7, this is minus 5, 1 plus 3 minus of 2. Now since all the values are less than 0, so it means now this is my optimal cost. Okay, and what our allocation says, x11, since this table is optimal, so x11 is 5, x21 is my 2, and so on, and the optimal cost is 76. So it means we needed 3 steps by using the northwest corner. So quickly look at when we solve this problem with the help of the LCA method, least cost method. So when you solve this problem, the initial basic solution is obtained at here, cost will be 83. Okay, now find the value of the UIs and the VJs are there. So I just start randomly, so I can assign say 0 here. So when 0 here, so this plus this is 1. Okay, so it will be 2. Based on this 2, I can use this value, so it will be again 2. Okay, now based on this 2 and 7, this value is come to be 5. Okay, now based on this 5 and this 4, this value is my minus 1. Okay, based on this 2, this 1, I can find the value of this as minus 1. Okay, now calculate this value, 2 ui plus vj minuscijb. Okay, so 2 plus 1 minus of 2, that is of plus 1. Okay, now to check whether this is optimal or not. So look at this value, this plus this minus 3, so it becomes the minus 3. Look at this value, 5 minus 1, 4, 4 minus 3, that is a plus 1. Okay, now look at the other values, this is over this, look at this value, this is minus 1 plus 2 plus 1 minus of 5, this is minus 7 is minus of 6. Look at this value, 0, this is my minus 5, this is over. Look at this value, this is 0 plus 5, this is minus 1. Okay, so check whether all are negative. Yes, no, this is a positive value are there. So it means this is my entering variable, assign as epsilon. You start from here, end at here. Okay, so what is the possible path is, you can turn always through these basic cells. So if I go on this direction, in this, then here, then here, then here, and this. So I can go in this way. Okay, then here. Okay, then in this way, and then this way. Okay, so this is my path. So this is plus epsilon, this is minus epsilon. Okay, this is my plus epsilon, this is my minus epsilon. So what is the value of the epsilon is all those values which contain negative epsilon, that is a 3. Always represent this is the allocation speed. So that is a 3 and negative is my 7p. Okay, so that is minimum of 3 and 7p. It comes to be 3. So look at this. Now it becomes a 3 epsilon. 3 minus 3 0. Leave that. 3 plus 7 is now 10. 7 minus 3 is now my 4. And the remaining, again we need a 6 values. The remaining 3 values are remain same. That is 2. Here is my 8 previous value. Here is my 7p. Okay, now 6 values are there. You can check whether they are true or wrong. 5, 8, 7, 14, 7, 9, 18p. Okay, so what will be the cost is? So cost is my, so previous value is my 83. What is the epsilon is my 3. What is the entering variable is this one, and value of this entering is 1. So it comes to be 80. Or otherwise you can multiply 3 into 2 and so on. Now calculate the values of the UIs, VJs are there. So I can assign any arbitrary value. Look at that. This time I assign a V1 0, say. So this plus this is come to be 2. Okay, this come to be 1. With the help of 2, I can calculate this value as a 5. Okay, so based on this 5, what is that? This value is my now minus 1. Okay, now if it is -1 and look at this +1 and this one is come out to be my 1 and this one is my 0. Okay, so now calculate the values of the Dij for those unoccupied cells. So 1 2 plus 1 3, 3 minus 4 is -1. This is now -3. This is now my plus of 2. Now this is my 2 minus, so 0 minus 1 5 6, 1 minus 1 0. It is now minus of 7, and the last value is here. 5 plus 1 6 is a 0. Okay, so is there all values are of less than positive are there, all value less than? No. So here is still one value is the positive value. So you can start from here, take epsilon. Now what is the loop is there? So start from here. If you go on this side, this side, this side, this side, this side, and so on. Yes. So if you start from here, go in this way, then in this way, then this, okay, this, and this. Always remember you can't cross for the diagonal wise. So this is my plus epsilon, this is my minus epsilon, this is my plus epsilon, this is minus, this is plus, and this is my minus epsilon. So that's the value of the epsilon is there. So here is my minus is 8, minus is my 4, minus is my 2b. So the minimum value is my 2b. It means this is not the optimal 1b. So it means we have to move for the next table b. So I just draw here again. So what is the value of the allocations are there? So now epsilon is my 2. So I just entering here. So I assign this value as my 2. Okay. So 8 minus 2 is now my 6. Okay. 10 plus 2 is my 12. Okay. 4 minus 2 is my 2. 3 plus 2 is my 6. 2 minus 2 is 0. And there are the 5 allocations and the remaining one is this one b. Okay. So look at that again. Now look at this is wrong b. So 3 epsilon is, look at that. Now I 6 but exactly 5. It means something is wrong b. Since epsilon is 2, so 3 plus 2 is my 5b. 5, 8, 7, 14, 5, 7, 9 and so on. Now calculate the Uij again. Okay, so I can assign this value as a 0 for example. So now this again, what is the cost of this is? So what is the cost of this one? This is my previous case. Okay, so what is the cost is? Previous cost is now my 80. Okay, so now the new cost is 80 minus what is epsilon is my 2. Okay, what is the entering variable is here? 2b. So 80 minus 4, that is 76. So check whether this new BFS is my optimal one or not. So what is that? This is 0. Based on this, you can calculate V1, V2 and V3. So if it is 0, it comes to be 3, it comes to be 1. Based on this 3, you can calculate this value as a 1. Okay. Based on this one, you can use this, it comes again 1. If it is 1, again this value is come to be 0. And if it is 0, it is come to be 2. Now you can calculate this value. So this value is come to be 3 plus 2 minus 7. So it's this. This is minus 1. This value is 0 minus 3. Okay, 0 plus 1 minus 4. 1 plus 1 minus 7. And 3 plus 1 4 minus 6 minus 2. Now since all values are negative, okay, so it means this is my optimal one. Okay, so remember previous northwest case is also my 76 the solution, and this answer remain the same. Okay, if you go back and then see that this x11 is 5, x22 is 2, and then so on, so answer is remain the same. So now quickly solve this problem with the help of the WAM method. You will get 5 these allocations are there and the initial cost is 60. Okay, so now again calculate the values of the Uij. Okay, so I can assign, since this is the maximum allocation, so I can assign 0 here. So it is easily 1, it's 6, is 2. Based on this one and this 2, I can calculate this value 2. Based on this 2, this one, I can calculate this value as minus 1. Based on this 6 and this 4, I can calculate value as a minus of 2b. Now calculate the values of the Dij for this. This is 6 plus 1, 7, 7 minus 7, 0. 2 plus 3, minus 4, that is minus 1, 6 minus 1, 5, 5 minus 3, 2. So it's a positive value. It means this is not an optimal solution B. So this value is 1 plus minus 1, 0. It's minus of 3. This value is my 2, 2 minus 2 plus 1 minus 1 minus of 6. This value is my 0 minus 7 and so on. Now since all values are not negative, these are two positive values and the most positive value is this B. Okay, so you can assign epsilon here. You can start from here and ending again at here through these blue circles are there. So you can go this to here, then here, then here, then here, and then here. Okay, so this is the easiest way. Okay, so this is plus epsilon, this is minus. Remember, this is not an epsilon because there is no turning. You can't left or turn is there. So minus epsilon, this is plus epsilon, this is minus epsilon. So what is the minimum is negative value 2 and 8. Okay, so what is that? Now this is my entering variable 2. Okay, so now this is my entering variable 2. 2 minus 2, 0. So it means this is my leaving variable. X 4, 2 is my leaving variable. 10 plus 2 is my 12. 8 minus 2 is 6. Now I need a 6 values. The remaining values are remain same. Okay, so that is 2 and this is my 7. So again you can check 5, 8, 7, 14 and so on. Okay, and what is the cost of this is? Previous cost is my 80. Okay, minus what is the epsilon is my 2. What is the entering variable is this. So 80 minus 4, that is 76. Again you can check that 5 to the 10, 3 to the 6 and so on. Okay, now check whether this is my optimal one or not. So I just calculate the value of the uij and vj. So I can assign the any arbitrary value to be a 0. Okay, so let's say I then start, these are two values are 2. I say like this time I start with here. So this is my 3, this is my 1. Okay, based on this one I can calculate the last value. Okay, based on this and this I can calculate this value. This value is from the here, and based on this 3 I can calculate the value of here is 1. Okay, now calculate the values of the this one. 3 plus 2 minus 7, ui plus vj minus cij. So ui 2 plus 3 minus 7 is minus of 2. 2 plus 1, 3 minus 4 is minus 1. 0 plus 0 minus 3 is minus 3. All are basic. 1 plus 0 minus 4. You can always check that these basics will always be 0. Look at that. 3 plus 1, 4 minus 4, 0. Okay. So 1 plus 1 and minus 5. And the last value are there. 1 plus 3, 4. So look at that. All values are less than 0. So it means this 76 is my optimal one. And answers are remain same. That is 5, 2 and so on. Okay, so this is the common problem I solved with the help of Northwest, least cost and the WAM methods. So what is the summary among them? So look at that. When we solve this initial BFS by using the Northwest corner method, the initial BFS is come to be 102. When you go to the second iterations, it comes to be 82. When you, and third iteration is come to be 76, and it is my optimal one. While if you solve this problem by the least cost method, its initially solution is 83, then 80, then 76. While for the WAM method, it says initially is 80, and in the first iteration, that is after the first iteration, that it's come to be optimal. That is, in the WAM method, there is always be a less number of the iterations to reach the optimal one. So that's why WAM is always be a preferable. Okay, so if there is nothing to given to you that solve the transportation problem, always prefer the WAM methods. Sometimes this become in the initial step is itself the optimal one be, while in the Northwest and the least cost it can never be. Okay, there is a need of at least one more is there. So this is the basic overview that, so I prefer this WAM method always be. So look at there's some other types of the special transportation problem. How to solve such type of the problems when one or the more entries are missing. Look at that. This value is missing in the optimization table. Okay, and it says that the product D cannot be produced from the workshop V3 W3. Okay, and these are some capacities are there 90, 40, 60 and so on, and you can check whether this is balanced or not. So how you solve when something is missing in the table B? Okay, so firstly you have to check the statement if whether it's a minimization or maximization B. Okay, so if it is a minimization, you can replace this number, negative number, with the m, where m is very large number. The same as that, you have to solve the big M method. That is, in case of the big M method, how do you solve that? That is optimization problem plus m of the artificial variable for the maximization problem. Sorry, for the maximization problem, and for the plus of m is the minimization problem. So same thing for here. If the problem is minimization, you can write instead of the missing value as a m. While in case of the minimization maximization problem, okay, you can either firstly convert into the minimization problem and assign the m, okay, or otherwise firstly you can assign the minus m because of the maximization and then convert the minimization, and after that you can solve with the help of northwest least cost and any one of them. Look at the another type is there. This problem says that the now it's a final optimal table is given to you. Okay, it is not the initial table. Okay, it's the final table is given to you, and the dual variables are assigned to be here. So these are my duals. So it means u1 is given to be here, this is 2, this is 1, and it is given. And what is that? This is 1, this, it is given to you. Okay, and you have to find the optimal cost. So always remember what is optimal cost is Cij Xij. Okay, so this is the first method. You can solve this problem with the help of the two methods. So what is the Cij? Now these are my Xij. This is optimal table. So these are my Xij. So how you find the Cij? You remember that this is my basic cell, and for the basic cell, what is that? Ui plus Vj minus Cij always be a 0. Okay, so it means 2 plus 1. So what is the Cij here? See, 2 1 is 2 plus 3. So it comes to be 3b. Clear? And similarly for here, what is the C of 3 1 3 is come to be minus 1. What is that? Is Cij is my 3. Okay, here this is my 1. The cost of here is my 3. Cost of this is my 4, because this plus this is nothing but the cost. So this is 3. Okay, so now you can easily solve that. This is 3 into 20 minus 1 into 20 and so on. You will get their optimal solutions. Okay, second method. Instead of this, what are the second method is there? So apart from this, what is that? So you know that any other formula for this is my 1, this is 2 0 1. So what is that? This is the dual of the optimization problem. Okay, and you know that whenever whatever the optimal solution is there and the dual solution, the optimal final optimal answer remains the same. So look at that. What is that? This is u1. What is the a1? Always remember these are allocations. So what is that? This is 25, this is my 30, this is my 20, this is 30, this is my 20 20, this is 20 plus 5 is 30 and 35. So how you calculate that? Minus 1 into 25, okay, plus 2 into 30 and so on, 1 into 20, 3 into 30, plus this and this way. Okay, so that will be the answer. So the answer obtained by this way as well as Cij Xij are same. Here Cij you have to calculate it by using the rule ui plus Vij is C is equal to Cij for the basic cells. Okay, so that is one of the most important time. This is mostly asked in the quiz competitions as well as some other examinations are there. One more types are there. Solve this transportation problem for the minimization cost when these solutions are given to you. It means in this problem it is given to you that you can never solve this problem with the help of the northwest least cost of m, but it is given to you that you have to solve this problem. For example, in the simplex method, if I say this is the optimization problem and you start from here. Okay, so how you construct that? You firstly calculate the b corresponding to this and then find the b inverse b, and then you have to calculate these columns are there, b inverse aj and so on. Same for here. So what is that? This is there, x12 is my 30, x21 x12 is not the x12. Okay, so what is the x12 is here, this is my 30, x21 is my 40, x32 is my 20, x43 is my 60. Now check whether this is my optimal or not. Firstly, you have to check whether this is a balanced or not. So it is a balance, it's 150. Secondly, how many allocations are there? You need it before applying the Modi method is 4 plus 3 minus 1 6, but here only 4 are there. It means this solution is called as the degenerate solution B. So it means you have to firstly convert into the non-degenerate. So it means two allocations are less. So you have to add the two allocation arbitrary with the cost value are 0 B. So I can assign one cost value say here. Okay, so I can assign the one cost value say 0 arbitrary here. Now the second value I can't assign here, because if I assign value of this, then it becomes a box. Okay, so it is a dependent, so we always find the independent manner. So I again can't assign here, again it box B. I can assign here, yes, there is no box inside it, so I can assign it here. Okay, or you can find the smallest cost, that is a 2 and 2. So either you can assign this and so on. Now there are the 6 allocation. Now you can find the value of u1, u2, u3 and vi's are there. Okay, once you solve, this is the optimal answer. I just give it to you. You can try to solve it. Remember, in this problem, you are not able to apply the northwest. If you want to apply the northwest, then again it's the answer will be 300. But in this problem, it is given that you start with this table. And the last type is, there are some initial solutions are given to you, whether this is obtained by northwest, least cost of them, or any arbitrary are there. Check whether this is optimal or not. So x13, it means this value is given to you. x14, this value is given to you. x21, 31, 32, and how many you needed? And x34. So how many you need? 3 plus 4 minus 1, that is 6. So 4 and 6 are there. So it means it is a non-degenerate. So we need a 6 allocations. Now calculate the UIs are there. Okay, and find the optimal solutions B. So if it is optimal, it comes to be 160 B. And how you find the optimal solution is it optimal? Then find its B. Okay, so the optimal solution is come to be 1160. So I hope this complete overview will help you to understand the methods again. So try to solve their problems and best of luck. Thank you.